Hello, and welcome to T-Level Tactics and this video on storing data for Root Core 3 data on the T-Level Digital Support Services course. In this video, we're going to outline types of local storage, compare cloud storage methods, and propose a data storage solution. Before we get started, these videos are not endorsed or sponsored by any education institution or qualification awarding body. And T-Level Tactics videos should not be used as a replacement to any classroom learning you might be receiving, as discussion and practical activities with your peers and lecturer will help to expand your thinking and comprehension. Instead, these materials are best used as preparation or as revision to reinforce your learning. And these videos cover the same content and required knowledge for Root Core 3 of the T-Level Digital Business Services course. However, they will be more contextualized towards IT support roles. Let's start off with some local storage. Local storage refers to anything that is kept on-site or on premises. It doesn't matter what kind of data it is, but the physical location and storage medium of that data must be owned by the individual or organization. Now, databases can be saved in a variety of formats depending on the software you're using. And the database file contains the structure of your database, tables, entities, relationships, data types, and usually all the data within those tables as well. Some examples of database files you might encounter include Microsoft Access databases, SQL Server databases stored in the MDF format, SQLite databases, FileMaker databases, and OpenOffice databases. Simple databases can contain all of their data within a single database file. However, more complex databases can use multiple files to import and regularly update data. They'll also use a file structure if they save and contain any additional media such as images, video, and documents. Now, most operating systems will use a hierarchical folder directory to organize files, where files will be stored in folders which can themselves be contained within other folders, and of course each of those folders can contain different files, whether they be text, video, audio, whatever it might be. It can get confusing, as you can see on this example on the right-hand side here, so appropriate folder naming is going to help to understand locations of saved data later on and help you locate it. All data is going to get saved to a physical device. This is most likely to be either a hard disk drive, or HDD, or a solid state drive, an SSD. Now, other storage types are available, but not often used for frequent access of data. They could be more suitable for backups, though. Hard drives are comprised of a number of magnetic disks that spin extremely fast, and microscopic sections of each disk can be polarized positive or negative by a read-write head. That same read-write head can then detect the polarity of each section. And the positive or negative polarity that's present in that section represents ones and zeros, or binary, that the computer can then interpret and present as a file. And in the images on the right here, you can see that read-write head, very, very tiny needle on the end that's used to change the polarity of the sections on those platters. Now, although the disks can spin very, very fast, up to 15,000 times in a minute in some cases, hard drives are actually relatively slow at storing and retrieving data. As the drive becomes fuller, the read-write head needs to wait for an available section to rotate to its location before it can write any more data. And this can lead to data fragmentation, where multiple parts of the same data are spread over the disk. Alternatively, data could be written in a continuous segment. However, other data might need to be moved first, making this write process slower. Most hard drives also have a maximum read-write speed of roughly 125 megabytes per second. And because of those spinning disks, any small vibration could cause read-write errors or even permanent damage. Regardless of the drawbacks, hard drives can be very affordable for large storage capacities. If you're working with smaller files or less frequently used databases, read-write speeds may not matter so much. You can see two examples here from Amazon, both 4TB drives, one from Seagate, one from Western Digital, and they're priced at £89 and £99 respectively. By contrast, SSDs, solid-state drives, are very different. Rather than spinning magnetic disks, SSDs use flash storage chips to save data instead. These chips have billions of microscopic transistors, essentially very tiny switches, that can change their state between 0 and 1. SSDs can come in multiple different form factors and can use different connectors. 2.5-inch SSDs, like the one in the top right image here, often have SATA connectors and are compatible with older computers that previously used hard drives, so there's a nice upgrade path there. M2 is a newer style connector that allows an SSD to connect directly to a motherboard and also supports much higher read-write speeds. M2 uses PCI Express lanes on the motherboard. You can also get expansion cards for PCI Express slots to add additional M2 format SSDs. You'll find out more about this in Root Core 5 Digital Environment. As SSDs rely on chips to store data, the data is available immediately. The lack of mechanical parts also makes SSDs much more difficult to accidentally damage through movement or vibration. Newer SSDs have a read-write speed of around 7,000 megabytes per second, which is considerably better than the 125 megabytes a second of a hard drive. However, they are much more expensive than hard drives due to the technology required to manufacture them. And here's an example from Samsung. It's 4 terabytes again, but this one is £268. You can find 4 terabyte SSDs of different prices. They can be cheaper, but if you want to try and get that maximum read-write speed, it does come at a premium. Now, portable storage refers to, well, other devices like USB drives, external hard drives, and external SSDs. And they're designed to be small form factor for easy transportation. They can be slower than the permanently attached versions that would be inside of your computer's hardware. And really, portable storage like USB drives and external flash drives shouldn't be used for permanent storage of data. It is, however, perfectly fine for a backup, but not as a replacement for an off-site backup. You can also get file servers. And file servers are used where multiple people need to access the same data, or where large quantities of data need to be stored and accessed in multiple places. A file server is often going to have much larger amounts of storage available, using multiple hard drives and SSDs. They can also have redundant drives which can contain duplicates of data in case of failure. This uses a system known as RAID. File servers are accessed over a network and can reduce the amount of data stored locally on each individual computer in the organization. You can also get network-attached storage devices. Network-attached storage are devices that can be connected to a network and can function as a file server. And network-attached storage devices, or NASes, are available in different capacities and configurations. They're completely separate from other devices and servers, so data should be available all the time. And they're designed with redundancy and data integrity in mind, but separate backups are still required. Network-attached storage devices are relatively cheap to get, and you can buy them online for less than £100. However, this is often without the hard drives or SSDs that you need to add to them to store data, so the cost can vary depending on what you want. Now, when you've got lots of NASes or network storage devices together, you can use a storage area network. You can create one of these. And on a storage area network, you can distribute the data over lots and lots of devices, and that data can be split into blocks. These blocks will be spread across devices, which makes it much quicker to access, retrieve, and usually to write the data as well. And storage area networks are usually connected with high-speed cabling, like fiber optics. Storage area networks are great as they can be expanded easily by connecting additional NASes or devices further down the line, but they can be difficult to configure and maintain, and will often require an administrator to monitor the infrastructure. Data warehouses are a good example of a storage area network. So for our Patreon members, this brings us to task 1 that you can find on the task sheet at patreon.com/tleveltactics. Now, if you're not a member, head over there and take a look. There are some free resources. You can also sign up to get access to that task sheet and get started on it now. So have a look at that first task. It's only a short one. It'll take about 15 minutes. Pause the video here, have a go, then come back when you're ready to move on to part 2. Let's take a look at some cloud storage now. Now, cloud storage is off-site data storage that's accessed over the internet. It's frequently purchased as data as a service, and it's essentially allowing you to store your data with another provider, somebody like Microsoft, Amazon, or Google. Now, to users, cloud storage systems use a similar hierarchical format to local storage systems. When you explore the interface and you save files, it looks very, very similar. However, the actual provider could be storing that data across multiple storage devices and even in multiple locations. One file could be held on a server close to your location as it's accessed regularly, whereas other data you store with that provider could be held on another server entirely as it could be less frequently used. Similarly, in a single data center, data can be held across multiple storage drives to speed up access times. And data centers often hold data for multiple customers. Now, to ensure that people get the right data and don't end up with the wrong data, access controls and permissions are in place to make sure customers can only access what they should. This is known as siloing. Cloud storage works in one of 3 ways, depending on the use case and requirements. There's file storage, object storage, and block storage. File storage method in the cloud is very similar to local storage in that hierarchical structure we looked at before. Users will see a list of files held in directories, and each file and folder can have individual access controls and permissions applied depending on who you want to be able to access it. It's great for user-friendly file storage systems where users need to interact directly with it. Object storage is a little bit differently. Data is not directly accessed by users through a folder structure, and instead this kind of storage is used by websites or databases where users will interact with them and they will then find the appropriate data based on their query. Objects are files, and all of their associated metadata stored together. And each object is given a hashtag to ensure it is an individual, unique item. If that object is used multiple times in different locations, on a website or in a database for instance, only one copy of it is required and stored, and all instances can use the same hashtag, and it can just be recalled from whatever location that unique item is held in. Block storage is the final type, and it's best used for datasets. Now, block storage breaks files and data down into multiple different blocks that can be different sizes. The data within each block can be edited directly and doesn't require the entire file to be loaded. This can be much quicker when working with large, complex datasets. Databases can also be moved to the cloud in their entirety. This will move all the processing required to run queries and generate reports to cloud-based servers. It could be provided as database as a service. Now, if the data is stored in the cloud, then this can provide a fast system that can be accessed remotely from anywhere. It doesn't require any powerful hardware in order to query the database. Microsoft Azure SQL is a form of this cloud database solution. We'll store all of that data in the cloud, and the application runs there as well. So time to take a look at task 2 if you're one of our Patreon members, all about cloud storage. So head back to the task sheet, have a go at this second task. Again, it's not going to take too long, roughly about 20 minutes. Pause the video here, have a go, then come back when you're ready to move on to part 3. Okay, we've identified different ways of storing data. Let's have a go at proposing a solution for a scenario. Both local and cloud storage solutions can be suitable, depending on the user requirements. Cloud systems can often be cheaper and quicker to set up, but can take some control out of users' hands. And data security is as much the provider's job as it is the customer's. There's another layer there you need to consider. Local storage can be more expensive and require more setting up, but you own every part of it. You can have more direct control over your data and systems. So which one's better? Well, let's take a look at a scenario together and have a think about what would work best. Here we go. A group of university students, the House Share, are working on a research project focused on sustainable urban development. The project involves collecting and analysing data from various sources, including surveys, environmental sensors, and academic articles. The students need a reliable data storage solution to facilitate collaboration, data sharing, and analysis. So what would you propose for this purpose? Would you recommend a cloud storage solution that potentially incorporates a cloud database? Or would you recommend a local storage-based system that they could keep in their House Share? How much do you think your idea would cost? Well, if you're a Patreon member, that's what task 3 is all about. There's some additional details on the task sheet for you to get started, so go back and have a read of that, and you can have a go at this third task. It is slightly longer. It's going to take you longer, somewhere between 30 to 45 minutes. Now, if you're not a Patreon member, then you can think about these ideas in that scenario and have a go yourself, but you can always join the Patreon, download the task sheet, have a look at that additional information. You can come up with a much more robust solution idea. Pause the video here, have a go, then come back when you're ready to finish things off, and we'll finish off with some exam questions. Okay, we've reached the end. So in this video, we've outlined different types of local storage, we've compared some cloud storage methods, and we've had a go at designing a data storage solution for a scenario. Let's have a go at 2 exam questions. Here's the first one. What are the differences between a hard drive and an SSD, solid-state drive? And the second, what are the 3 different cloud-based data storage methods? That brings us to the end of the video. In the next video, we'll be looking at information systems and what they can do for us. So make sure you're subscribed at youtube.com/@TLevelTactics to be notified when that comes out. And if you haven't looked at the Patreon yet, head over to patreon.com/TLevelTactics to take a look at all the exclusive content that our members get, including the task sheets, additional resources, and the exclusive podcast editions if you link your Spotify account as well. Thanks for watching, and see you next time.